Welcome, everyone. My name is Sam Agan with Accutech, and I'll be moderating today's webinar. First, some information on the meeting platform. The navigation bar on the left includes a button to make the presentation full screen, a button to switch the audio to phone, and a Q&A button to submit any questions you may have, which will be answered at the end of the presentation. Today's webinar on inadvertent mixing is the fifth and final webinar of Accutech's five-part summer webinar series on process safety topics. Founded in 1994, Accutech is a global leader in process safety and security, providing management and technical consulting services, world-class training, as well as enterprise risk management software. Today's session will be led by one of Accutech's incident investigation experts, David Heller. David is a senior principal engineer with Accutech. He started his career in process, plant, and production engineering and has been in the safety field since 1984. He spent 5 years as a plant safety manager with Cytec Industries and held corporate PSM roles with American Cyanamid and Cytec. He was a lead investigator with the Chemical Safety Board from 1999 to 2005 when he joined Accutech. I'll hand it over to David now.
Thanks, Sam, and thanks everyone for joining us today. What we're going to talk about today is inadvertent mixing. So if you look at the OSHA PSM and the EPA risk management standards, they both mention inadvertent mixing, but it's really just kind of one line under process safety information. So if you look at the process safety information section in the PSM, OSHA PSM standard, it's divided into three parts. One part is information pertaining to the hazards of the highly hazardous chemicals in the process. And then the subpart of that is hazardous effects of inadvertent mixing of different materials that could foreseeably occur. Of course, PSI then becomes input into many other parts of your PSM program, your hazard analyses. It helps you put together your operating procedures and training, and it really informs all parts of your process safety management program. Now, serious consequences can occur if inadvertent mixing is not prevented. So today, we're going to spend the majority of our time talking about one case study that the Chemical Safety Board did for an event from 2016 at MGPI Processing in Atchinson, Kansas. We're going to look at some lessons learned from that incident, and then we'll talk about some ways to maybe incorporate your inadvertent mixing information into your process hazards analyses. But first, I'd like to take a look at some other inadvertent mixing incidents and also kind of how your inadvertent mixing program can be put together and organized and used. So the first step is obviously to understand what the chemicals are on your site and understand which are compatible and which are not. There's a couple of ways or avenues to do that and develop this information. Your SDS sheets are going to have some basic information on compatibility. Often not going to go far enough, though, so you're going to need a little more help than that. Now, for many years, NOAA in the U.S., the National Oceanographic and Atmospheric Administration, hosted a chemical reactivity tool. It's a free program, and it's now available from the Center for Chemical Process Safety of the American Institute of Chemical Engineers. So this program has a database of thousands of chemicals, and it's a great starting point for putting together a compatibility matrix. Here on the right-hand side of the slide is a screenshot from the CCPS chemical reactivity worksheet. You can do literature searches, help you provide some information. Often if you have a unique or newer type chemicals, you can base your interactivity matrix on chemical composition or the active parts of the chemical molecule. You can also do reactivity testing if you've got something that's really unique or something that's unusual. And there are a number of commercial laboratories around the world that will take your products and run them through a battery of tests and help you figure out what's good and what's bad. So what happens then after you've created a reactivity matrix? Does it just sit in a binder or a folder and get pulled out when your PSM auditor comes around every 3 years to ask about inadvertent mixing? So if you haven't already done so, you really need to evaluate your processes versus that matrix. Where there's hazardous combinations that are possible, you need to determine if there are ways that those substances can actually get together at your site. And what you're trying to do really is determine if you have sufficient layers of protection to prevent that mixing. Now, the layers of protection can be administrative, labeling, for example, or they can be engineering protections, maybe different types of connectors used for different types of connections. And again, with this information, it can be used part of your process hazards analysis or your HAZOP, and you use your risk matrix then to evaluate the likelihood and consequences of that inadvertent mixing, and really to determine if you have sufficient layers of protection in place. If you don't, then that matrix will give you, your risk matrix then will give you some prioritization for deciding what you need to add as far as additional safeguards to get where you feel safe enough on that interaction of chemicals. And if you bring a new chemical into your site, you should certainly go through any potential reactivity issues. You might have a line on your management of change forms to make sure that you've looked at potential interaction issues if you're bringing a new chemical on site. And a lot of sites have a checklist. They may even call it often a new chemical checklist to ensure they've looked at what sort of interactions could be occurring. So inadvertent mixing, unfortunately, all too common. Events are happening all the time, all over the world. This first event was at a Buffalo Wild Wings restaurant. An employee released chlorine gas. He was mixing a cleaner that contained phosphoric and nitric acid. He mixed it with another cleaner that contained sodium hypochlorite or bleach. A manager trying to clean up the mess, he was overcome by the fumes and actually died at hospital. So even when you don't know much about an event or you see an article like this in the newspaper, there's often ways that you can think about it and even speculate on what could have gone wrong and are there lessons learned for your own site. So here we have 3 different people involved in the incident. Maybe there was a lack of understanding of the hazards by one or more, or maybe there was poor communications, all kind of safety culture shortcomings that maybe could have prevented this one. Another event, this was at a brewery in Denmark back in 1997. Here, an operator confused mixing nozzles, and he added nitric acid into a vessel that contained a cleaner that had 5 to 15% isopropanol in it. And it's likely that this inadvertent mixing produced isopropyl nitrate, which is a rocket propellant. The tank disintegrated, fragments lodged in concrete walls. So again, quite a violent inadvertent mixing event. Here, the article I referenced noted that the operator had confused filling nozzles. That could be poor labeling, poor training, poor procedures, or maybe even pressure to get the work done that led to the operator, not taking as much time to think things through as he should have. Here's another event. This was also investigated by the Chemical Safety Board back in 2002, and this was at a paper mill. So sulfuric acid here was being added to a sewer for pH control. That was kind of normal practice for them. Farther down the sewer line, the site was receiving delivery trucks with sodium hydrosulfide, or NaSH. They were being unloaded, and with each unloading, you had a little bit of not inadvertent, but kind of small leaks from breaking and breaking the pipe connections and hose connections. They're connecting all those little droplets here and there into a collection pit. And after they had unloaded like 15 trucks, they drained that collection pit into the sewer. Well, the NASH reacted, the NASH reacted with the sulfuric acid, produced hydrogen sulfide gas, H2S. The H2S moved along in the sewer. Again, this was an underground sewer, but there was a poorly sealed access manway, and the H2S got out above ground where it impacted a maintenance crew who was working near that manway. 2 of the maintenance crew were killed and another 8 were injured. So here there were really 3 unrelated events: sulfuric acid going in normally, truck unloading, and a maintenance crew. So what was going on here? Maybe situational awareness would have helped, maybe some more hazard recognition as the work was being set up, and even consideration of SIMOPS or simultaneous operations could have been helpful. Again, lots of events and lots of things to learn. Now I'd like to spend some time on kind of the event that's we talked about at the start here. This is at MGPI Processing in Atchinson, Kansas. So MGPI Processing processed grains, and they made alcohols, they made wheat starches and proteins, and other specialty products. So this event was due to an inadvertent mixing of sulfuric acid and, again, sodium hypochlorite or bleach that produced chlorine gas. The event led to shelter-in-place orders. There were evacuations from schools. 140 people sought medical attention. 6 people were hospitalized, and fortunately, all were released within about 5 days of the event. So the MGPI plant was receiving tank trucks of materials, various materials. Here you can see this purple little tag marks the unloading area. And they were unloading trucks of sodium hypochlorite and sulfuric acid. Hypochlorite in orange, the sulfuric acid in red. The sodium hypochlorite was 12.5% solution, and the sulfuric acid was a 30% solution. Again, all coming in by tank truck. The fill connections were located behind the lock gate, and each of the fill connections had a locked dust cap. So normal operation was for the truck to arrive after they went through the regular paperwork process. The truck would come to the unloading location. The operator would unlock the gate, open the gate, and unlock the proper line cap for the truck driver. The operator would then watch the truck driver make the hookup. The operator was charged with opening the valve between the connection and the tank truck. And then the truck driver would unload. The operator could leave, and after the truck driver was done unloading, he'd unhook, lock things back up, lock the cap back on, close the gate, and he was done. So what happened on the day of the event was this. A shipment arrived, 30% sulfuric acid. Paperwork was handled normally. An operator met the driver. They went out to the unloading spot, and the operator unlocked the dust cap on the sulfuric acid line, pointed the connection out to the driver, and at that point, he left. Well, the sodium hypochlorite unloading point was also unlocked, and the driver mistakenly hooked up his sulfuric acid delivery to the hypochlorite line and began unloading. Generated a chlorine cloud. Chlorine cloud came out of the hypochlorite tank, and as a result, no one was able to reach the tank truck to stop the unloading. 45 minutes later until emergency responders were able to isolate the tank truck. But in that time, about 4,000 gallons of sulfuric acid were added to the 5,800 gallons or so that were in the hypochlorite tank. And it took another 3 hours before the all clear was finally sounded for the community. You see, CSB's investigation followed multiple paths. It's rare for an investigation to really uncover one straight line of cause and effects, bang, 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 like dominoes leading to an incident. Most of the time, there's multiple paths, multiple contributing factors that line up in time and space to cause the incident, and this was no exception to that. So CSB was pretty easily able to identify a number of human factors shortcomings really that led to the event. So first of all, the 4 fill lines were identical. There were only 18 inches separating the 4 of them at the unloading station, right pretty much on top of each other. The padlocks that were used on the dust caps and the dust caps were all identical, and they were all keyed the same. So you could use the same key to unlock any one of those 4 dust caps or any one of those unloading lines. The connections were not labeled well. That red circle shows the label on the propylene oxide line. It was very small. And even some pipe markers were missing or wrong. In fact, the sulfuric acid line going from the unloading station to the sulfuric acid tank was actually labeled as a hydrochloric acid line. So that was wrong. There was no color coding on the lines really to help you either. So those were all issues right there at the unloading spot. There was a checklist for doing the unloading, but the checklists were not consistent. The sulfuric acid checklist did not have spaces for the operator to document or verify each step, while the hypochlorite procedure did. And having a checklist with steps and spaces to allow the operator to kind of walk through them step by step with initials and times really helps ensure that nothing is glossed over or rushed through. Now here you see on the left the hypochlorite procedure with the really well laid out steps, 1 step per line, place to sign off or initials, time and date, and on the right the sulfuric acid procedure, which is a little more looks like prose rather than a procedure or a checklist. MGPI had no means to remotely interrupt the unloading process. There was only the only shutoff valve where it was the emergency shutoff valve or a switch that was on the front end of the tank truck. And when the chlorine cloud started, the driver had to leave the area and was unable to get back and hit that switch and close the valve. There were problems between practices and procedures. Like I mentioned earlier, the operator was supposed to verify the hookup and open the valve. And on this day, he just left after pointing out the hookup. In fact, there was CSB found some confusion even among the operators after about what the proper practices should be. MGPI had a program where line managers would monitor field activities to kind of check for that sort of discrepancy between practice and procedure, but they never identified any issues with the unloading process. So they weren't documented, and these differences weren't addressed. So the CSB's report then listed a number of things to consider evaluating your unloading systems. And in this situation, MGPI made changes very quickly, and the CSB actually included some after pictures of the MGPI system in their report. So kind of a before and after. So CSB would ask you to think about can fill lines or receiving vessels for incompatible materials be isolated or separated by distance? And can you do a good job of labeling so drivers or even operators can locate what they're supposed to do and where they're supposed to be? And here you can see that MGPI has created 2 separate locked cages, if you will, for unloading 2 of the different materials that they were handling, and with nice, very clear labeling on each one of those cages to identify what was what. Other things to think about, respect to hierarchy of controls. So MGPI relied a lot on procedural safeguards. Again, just the labeling, the operators following the procedure, going out there with the driver to explain what's going to happen. There were no active controls, which would be maybe shutdown valves activated manually, or maybe a shutdown valve activated, from a distance from where the unloading is taking place, so the switch can be reached in the event of a spill, or maybe even in response to chlorine monitors closing a shutdown valve, and there was certainly no consideration of passive controls. Maybe they could have substituted a less harmful material or received less of the material. Could unique fittings on the lines have helped? In some plants, you see maybe like for air and nitrogen, different types of hose connections are used just to make sure that you don't inadvertently hook up air to a nitrogen line and mess up your inerting system, or nitrogen into an air line that might be used for breathing air. But you can do that with other types of materials in your plant as well. However, I can tell you about an event I once investigated. Truck driver pulled up to the wrong tank at the plant. He found a different unloading fitting than what he was expecting, because the plant had taken some steps to put in unique fittings. Well, the truck driver had a box full of miscellaneous fittings in the cab of his truck. So he was got out his box of fittings, and he was busy jury rigging a fitting that would work, when luckily an operator saw what was going on and came over and stopped him kind of in the act. So even those unique fittings can be defeated. Other things to think about that CSP mentioned in their report. Work with your chemical distributor to agree on procedures. Make sure you've looked at that for each of the chemicals and for each of the distributors that you're dealing with. And maintain ongoing discussions with those distributors. If your plans change or your procedures change, make sure that's communicated to the distributor. If they have somehow made a change in their type of equipment, their unloading equipment, hoses or truck pumps or whatever it might be, make sure that they're communicating back with you. Are your drivers and your operators working together to make sure that things are verified? Again, that verification step can be really important. One person could be distracted thinking about here's the weekend, but having two people helps make sure that they're not going to miss anything and make sure that connection goes properly. Are the responsibilities of that unloading clearly understood? What is in the operator's domain, and what are the driver's duties? And in an emergency, are the responsibilities clear? Do the truck drivers know that there's an emergency stop button located 30 yards from the unloading point on a post? And do they know how to activate that and how to maybe get help if they need it in the event of emergency? So these are just some considerations, things to think about. Again, looking through these case studies often gives you a lot of food for thought, and that can help improve your processes. I'd like to give you a couple of additional thoughts for your PHAs, for your process hazards analysis, when you're unloading materials, or for that matter, you'll see when you're loading materials. These thoughts can be rolled into your HazOps. You're doing hazard and operability. You can create a checklist to cover some of these unloading issues and pull out that checklist, walk through it every time you do a unloading operation for an operation in your plant. So some things to think about. Review the unloading process really from beginning to end. And that includes the truck arrives at the site. How do you verify it's the right material? Is there a testing involved? Are there certificates of analysis that need to be examined, and by who? And then who directs that driver to the unloading spot? And often it might be easier to use a checklist or a what-if approach for unloading operations and trying to shoehorn the unloading process into HAZOP deviations. After all, HAZOP really is just organized what if. What if flow rate is too high? What if flow rate is too low? What if the flow goes someplace where it's not supposed to go? So a checklist can really help you, again, for consistency from unloading operation to unloading operation. Review your unloading procedures step by step. You might have steps out of order. You might have steps that are missing. I once was doing an unloading PHA, and just a simple step like chalking the wheels of the tank truck was omitted from this one procedure. Think about inviting a truck driver or a representative of the distributor, someone with practical experience, to participate in the unloading PHA. Now, you might be doing an entire process, and the unloading is just going to take one day or a half of one day of a couple of week-long PHA. So bring the operator in for that half a day. The driver in for that half a day, and you'll be surprised what you might learn from that interaction. Again, just as good as having the operators in the HAZOP is having the guys that are actually doing the work there. And also, again, if you're loading product or loading intermediates, go through the same process. Look at your checklists, go through the procedure step by step, and think about what can go wrong during unloading. Pretty much often the same as what can go wrong during loading and unloading. So that's bulk materials. But I know a lot of you are also dealing with smaller quantities as well. Plant where I was safety manager had a lot of batch operations, and we were dealing with drummed quantities. We were dealing with totes. We were dealing with super sack bags, and all those again can present inadvertent mixing problems. So, is it possible to confuse similar materials, bagged materials or drum materials? Could an operator confuse a nitrite with a nitrate? Are similar materials stored in close proximity in the warehouse? Could someone go up to the wrong material and pick it up and bring it over to the production floor? Again, when I was a safety manager, we had incidents like this. We had the wrong drum material brought up from the warehouse to the floor, same color drum, different chemical. We had mistakes with two similar bags that contained very dissimilar materials that were brought up to the production floor, and I'm sure you've had similar misadventures if you've had any sort of interaction with these sort of processes. Again, walk through the process all the way through, from bringing the truck at the gate, getting those bags or drums or totes into your warehouse, and then following them along from the warehouse to your production to the reactor manway. Do you have sufficient verification steps? We sometimes call that the 4 eyes principle: the 2 eyes of the operator and the 2 eyes of the guy who's doing the check, the supervisor or another operator. And again, do you have other ways to mark down who's doing what, and time and date and initials? And really what you're trying to do with a lot of that is to put some speed bumps into your procedure to keep things under control and make sure that people are taking the amount of time they need to think about what they're doing and get it right. So that's kind of the bulk of what we wanted to show you today. Here's some options for more information. So, of course, the Chemical Safety Board's website, csb.gov, excuse me, has you have access there to all the completed investigation reports. Often they're accompanied by videos and other materials, great training tools for use in your plants, and very well put together. The CCPS chemical reactivity worksheet that we talked about early on in this presentation, that can be found at the AICHE's American Institute of Chemical Engineers CCPS website. And then often you'll find various chemical manufacturers lab supply companies, all those kinds of folks have online databases. This one from Cole Palmer has a database of compatibilities of their chemicals with various piping and vessel materials, steels, aluminums, gasketing materials, and rubbers, and all that sort of stuff. So it's that kind of a chemical resistance database. Again, there's other companies that have that same sort of information out there that you can use. It's available free of charge and open for everyone to use and stay safer. Okay, a little summary. Mixing incompatible materials, all too common event in the industry. Events can occur not only in process areas, but even in your cleaning operations. Again, think about the chemicals you have on your site, and not just in that big 2,000-gallon reactor, but sitting there in the maintenance shop, or sitting there in your cafeteria, storage pantry. Often, simple human factors and communications considerations can prevent these incidents, but a hierarchy of controls approach is even more useful in evaluating, if you have enough safeguards for these sorts of events. And finally, think about when you do your PHAs, looking at these unloading operations really from soup to nuts, from the material arriving at your front gate to when it's finally put into your reactor or into your process. I want to thank you for your time and for your attention. And are there any questions, Sam, that we can address?
Thanks very much, David. That's really an interesting topic. And as you mentioned, it does seem to be a recurring issue in industry, in the processing industry, and even outside of the processing industry in
right.
One of our regular day lives.
And don't forget that Bhopal, probably one of the most pivotal events in chemical process safety, was really an inadvertent mixing event, mixing water with methyl isocyanate.
Exactly, and that was what really the birth child of PSM was.
Yeah.
So we do have a few minutes remaining to answer some questions from the audience here. First question, how often should labeling be verified or maintained?
Good one. Okay. So a lot of plants, they'll have their operators will have a routine weekly housekeeping round. Maybe the shift that's on days, on Sundays, if you're working 24/7, has a housekeeping checklist that they run through, and that's a good place to have your labeling on there and check that out. The operators should be looking for that also, kind of just on their normal rounds, because things can get bumped and knocked off and displaced and weathered over time. But a regular event on a weekly or maybe even a monthly is okay basis is certainly a good idea to look for those. Look specifically for the labeling issues.
All right, thank you. All right, here's another one. Is there a requirement for different connection types for various incompatible materials? I guess that's in reference to the in the example we saw.
I don't know of any off the top of my head. Again, one to think about that you often see is how plants handle air versus nitrogen. You also want to think about often trying to make sure that nothing gets into your water systems, making sure that any connections there are unique.
Yeah, definitely. Definitely seems like that would be a good practice, but I don't know that it's a requirement. So definitely, for an event like that at your site, you might do some advanced. You might do some recommendations to really address that possibility, and there did seem to be a lot of issues with that unloading setup.
Yeah, I think often this is an opportunity, and if you're doing a good job of capturing often they're near miss events. Someone starts to hook up to the wrong place, or and realizes it before they turn the valves open. And if people are doing a good job of capturing those and feel comfortable reporting those, you can learn a lot from those near miss events.
Mm-hmm. All right. One last question that we have, which is more of a personal question. Were you one of the CSB investigators that were working on the MGPI release?
No, MGPI was after my time at the CSB.
Okay. All right. All right. Well, if there aren't any more questions, I guess that's all of our time for today. We'd like to thank you very much for participating in our summer webinar series. And you may direct any questions you may have or requests for how Accutech can further assist you to info@accutech-consulting.com. Thank you all for joining and have a great afternoon.